Assalamualaikum and hello everyone. My name is Humaira. Me and VONNY are going to present about Grignard reaction. So as you guys can see from the screen, Grignard reaction. What is Grignard reaction? It is a reagent that has an R group, meaning that some carbon chain bound to a magnesium metal and bound to a halogen, typically chlorine, bromine, or iodine. So this is a very reactive and very useful in elongation because it is the strongest of the organometallic that you're going to see. So again, anyway, what is organometallics? Organo tells us that we have carbon chain. We have carbon chain while metallics bound to metallic bound to a metal. Okay, so this is organometallics. So in this case, the carbon bond to the magnesium metal has such a difference in electronegativity that the magnesium becomes very partially positive, making that carbon very partially negative. That okay, almost to the point of being a carbanion. Okay, so this is side note. A carbanion is a carbon with a negative charge, a very unhappy group, and therefore very reactive.
So for the first example, this Grignard region react with ketones. So first we have cyclopentanone. It will react with CH3, CH2, MgBr, and H3O+. So first it will attack the pi bond inside the cyclopentanone, and it will give us the alkoxide ion. This is the alkoxide ion. So for the second step, the alkoxide ion will react with H3O+. So since the oxygen ion inside the alkoxide ion is negative and the oxygen in H3O+ is positive, so the alkoxide ion will pick up hydrogen from H3O+, giving us the final product of tertiary alcohol. So keep in mind that every time Grignard region react with ketones, it will always end up with tertiary alcohol.
Okay, this is the example on how to create a secondary alcohol by mixing a Grignard reagent with an aldehyde. Here's an aldehyde. It can be any length 1, and these are can be any carbon chain you want with a Grignard reagent. That is an alkyl halide that has been mixed with magnesium and ether to create this thing. Okay, which is the same as the alkyl halide, okay, but with an empty in between the carbon and the X. Okay, now in this molecule, the aldehyde, we have an electronegative atom, which is the oxygen. So I'll give it a delta minus. Okay, and this carbon is delta plus because it's connected. It's connected to the electronegative atom. Okay, thus we get a little attack, which is the lone pair of electrons. From the Grignard reagent, okay, we will attack the carbon. And in the process, it has to push the double bond between the carbon and the oxygen to become a lone pair around the oxygen. Okay, so otherwise the carbon would violate the octet rule. Okay, what we end up with is an R group connected to the carbon, still connected to the hydrogen. Okay, it's now connected to the R prime. It's now connected to the R prime group. And we are left with the oxygen, which is now has three lone pair as opposed to the two lone pair. So now that plus charge is actually mitigated by the fact that the MgX is no longer necessarily attached to this R group. Okay, this is no longer attached to this R group. This is R group. Simply mix that mixture in with some aqueous acid. It could be any aqueous it's like HCl or H2SO4 that just serves to have an H plus attached here. Okay, and you end up with that R and that R prime and that hydrogen all still connected to the carbon, but now you're left with OH. That's all.
So for the next example is when Grignard regions react with esters. Keep in mind that every time Grignard region react with esters, it can only include two R groups. So here we have esters and we will react with ethyl magnesium bromide and H3O+. First step, the ethyl magnesium bromide will attack the pi bond because we need to add the ethyl inside the esters. So when esters react with ethyl magnesium bromide, it will give us tetrahedral. So tetrahedral occurs when there are 4 bonds and no lone pairs in the molecule central atom. So this is gonna be the first R group. When tetrahedral is formed, here we can kick out this is supposed to be the methoxide ion. And when that happens, it will give us ketone. So for the next step, we will react with CH3, CH2 magnesium to form this product. And for the last step, we will react with H3O+, same thing, the hydrogen is taken from H3O+ to form tertiary alcohol.